Somewhere in China right now, a machine the size of a 5-story building is grinding its way through solid earth, 150 meters beneath a city street packed with millions of people. Buses rumble past overhead. Shops stay open. Nobody walking above feels a single vibration. And that's just one of a genuinely startling collection of machines China has quietly built over the past few years. Equipment so far beyond what most of the world is used to seeing that engineers on other continents are having to fundamentally rethink what construction equipment is even capable of doing. None of what follows is a prototype sitting in a lab somewhere. Every single one of these machines is already out in the field right now, building real infrastructure on real deadlines in some of the most punishing conditions on Earth. Start with something as basic as paving a road, because even that ordinary task has been quietly reinvented. In 2025, a Chinese highway project did something that had genuinely never been attempted before anywhere in the world. 10 self-driving construction vehicles rolled out onto an empty stretch of land and built a highway completely on their own. Nobody sat in a single driver's seat. Nobody operated a single set of controls by hand. The entire fleet moved in coordination, guided by artificial intelligence and positioned using satellite signals accurate down to the centimeter. By the time they finished, 158 kilometers of fully paved highway stretched out behind them. The centerpiece of that fleet was an asphalt paver capable of laying down a strip of road 19 meters wide in a single continuous pass, wide enough to cover an entire road and its shoulders in one uninterrupted motion. The AI running the operation wasn't just keeping vehicles driving in a straight line either. It was making hundreds of small decisions every single minute, rerouting machines around unexpected obstacles, slowing the paving speed automatically as the asphalt temperature dropped to keep the material at the correct thickness, and instantly correcting any vehicle that drifted even slightly out of formation. What surprised the engineers who actually built the system wasn't just that the finished road matched what a skilled human crew could produce. It didn't. It was measurably smoother, more uniform in asphalt depth, and more consistent across its entire length than roads built the traditional way, run by tired human crews working long shifts. The machines didn't just match the existing standard for road quality, they quietly raised it. Roads are only half the transportation story, though. China also operates the largest high-speed rail network on the planet, stretching well beyond 48,000 kilometers of track and collapsing journeys that used to take an entire day of driving down to under an hour by train. 20 years ago, almost none of that network existed. Building it at the pace China managed required its own dedicated piece of hardware, a track-laying machine called the CPG 500. Older rail-laying systems work in an inherently stop-start rhythm, placing a section of track, halting, repositioning, placing the next section, halting again. The CPG 500 throws that entire process out. It lays rail and sets the concrete sleepers underneath it simultaneously, rolling continuously forward without ever pausing between placements, functioning essentially like a rolling factory that produces finished, ready-to-use railway track behind it as it moves. In a single working shift, it can install up to 2 kilometers of completed track, handling individual rail sections up to 500 meters long, something older equipment simply couldn't manage, all while holding a margin of error of just 10 millimeters across the entire run. The CPG 500 has since been exported well beyond China's own borders too, laying track in Malaysia, Indonesia, and Serbia, and it built the very first railway line to completely encircle the Taklamakan Desert in Xinjiang, one of the harshest, most remote environments anywhere on the planet to build in. It might not look as visually dramatic as some of the other machines on this list, but measured purely by how many people's daily lives it actually touches, it may well be the most consequential one of the entire lineup. Building across dry land is one kind of challenge. Building across open ocean is an entirely different, considerably harder one. Picture a vessel roughly 300 meters long, close to the length of 3 football fields laid end to end, carrying a crew of around 380 people, floating out on open water. Now picture that same ship lifting a load equivalent to more than 8,000 cars in a single hoist, without tipping, without shaking, holding its position with the kind of steadiness you'd expect from precision surgery rather than heavy industrial lifting. This is the floating crane vessel built by the Chinese company ZPMC, widely regarded as the most powerful floating crane anywhere on Earth. Seen from a distance out on open water, it barely reads as a piece of construction equipment at all. It looks more like an entire floating industrial complex that happens to have a crane bolted on top, and the scale of it only really becomes comprehensible once you see it sitting next to an ordinary cargo ship, which suddenly looks tiny by comparison. China needed something on this scale specifically because of projects like the Hong Kong-Zhuhai Macau Bridge, the longest sea crossing structure ever built, stretching more than 55 kilometers across open water. Building that tunnel meant lifting enormous prefabricated concrete sections, carrying them far out to sea, and lowering them onto the seabed with a gap between adjacent sections narrower than the width of a human finger. get that placement wrong by even a small margin, and the entire tunnel floods, taking the whole project down with it. Each individual section weighed tens of thousands of tons, effectively the mass of a small skyscraper. And the crane had to carry that load across open water where waves never stopped moving, then lower it through the dark water until it settled perfectly onto an uneven seabed below, all while currents pushed from every direction and wind tugged constantly at the lifting cables. As the vessel swayed and the wind pushed against it, onboard sensor systems adjusted the lift in real time, keeping each concrete section perfectly aligned with the piece already resting in place below, with a margin of error measured not in centimeters, but in millimeters, out on the open sea, with waves rolling beneath the entire operation the whole time. In 2025, the very same vessel hit another milestone, lifting and installing an entire offshore wind farm platform in one operation, marking China's first ever installation of a 10,000-ton offshore steel structure. It handles entire pieces of infrastructure the way an ordinary crane handles a single steel beam, and there's genuinely nothing else in the world currently operating at that same scale. A conventional excavator or bulldozer is essentially useless on a steep hillside, in a flooded forest, on a narrow mountain trail, or inside a collapsed ravine. The wheels or tracks simply can't cope, and the machine slides, tips over, or sinks straight into the mud. China built something specifically for exactly those situations, a machine called the ET-120, developed by the manufacturer XCMG. It doesn't resemble a normal piece of construction equipment at all. It looks closer to a giant mechanical insect standing on 4 independently articulated legs, each one able to extend, compress, and pivot entirely on its own. Rather than rolling or driving, the machine genuinely walks, climbing slopes that would send a conventional excavator tumbling sideways, and crossing ground so soft and waterlogged it would swallow ordinary equipment whole, spreading its weight across all 4 legs and simply continuing forward. Online, people have nicknamed it the Steel Mantis, and watching it pick its way across a mountain slope no other machine could reach, the name fits almost perfectly. It wasn't built purely to look impressive, though. It was built specifically for the aftermath of earthquakes, landslides, and wildfires, situations where roads have been torn apart, hillsides remain unstable and ready to collapse further, and the ground is buried under debris, water, and broken material. Exactly the kind of terrain that's historically made it nearly impossible to get heavy equipment into a disaster zone quickly. The ET-120's arm accepts a range of different attachments, letting it switch between tasks without needing an entirely different vehicle brought in. It can dig through rubble to open a path, lift heavy concrete beams that have collapsed onto vehicles or buildings, cut through fallen trees blocking an escape route, drill through solid rock, crush debris down into manageable pieces, or deploy firefighting equipment directly, swapping attachments in a matter of minutes. Because it operates entirely by remote control, the human operator stays a safe distance away the entire time, guiding the machine from hundreds of meters back using a handheld controller and a live video feed, letting it walk into collapsed buildings, burning forests, or unstable hillsides without putting a single person directly at risk. China has already deployed these machines in genuine disaster response operations, planting their 4 legs into ground that would snap the axles of a normal truck to create a stable working platform, then reaching out with their arm to clear debris off trapped survivors or carve a path through for rescue crews following behind. A machine that walks through disaster zones is remarkable enough. Some projects, though, require going in the completely opposite direction, straight down into the ground beneath a living, functioning city. Beneath the busy streets of Beijing, 150 meters down, sits a tunnel-boring machine named Jinghua, over 16 meters across, 150 meters long, and weighing more than 4,300 tons. To put that width in perspective, it's wider than a 4-lane highway, and it's longer than a full-sized soccer pitch. Its job was to bore more than 7 kilometers of tunnel directly underneath central Beijing, part of a project to move traffic on the city's East 6th Ring Road underground and relieve the crushing congestion clogging the surface streets above. The real challenge wasn't the boring itself so much as the ground it had to pass through. Beneath Beijing, the soil isn't solid rock. It's a constantly shifting mixture of sand, underground water channels, and soft layers that compress and move whenever anything disturbs them. Its control systems continuously measure the surrounding ground pressure, automatically adjusting the speed of its rotating cutter head and the internal support pressure in real time as the soil conditions shifted, responding the way a surgical team monitors a patient throughout an operation. Every millimeter of progress got tracked and logged, and if the machine drifted even slightly off its planned path, onboard computers corrected it immediately. As it advanced, Jinghua didn't just carve a hole, it simultaneously built the finished concrete tunnel walls behind it, leaving a completed tube in its wake, rather than requiring a separate lining process afterward. Throughout the entire operation, not a single crack appeared in the roads above. No sinkholes opened up and no buildings were damaged, meaning the millions of people going about their lives directly above the machine never had any indication it was even down there. In its most productive month, Jinghua advanced more than 500 meters of tunnel, and when it finally broke through on the far side, it had completed one of the most technically demanding urban tunneling projects ever attempted anywhere in the world. What makes this even more striking is how recent China's dominance in this specific technology actually is. Just 20 years ago, the country didn't manufacture machines like this at all, importing them instead from established suppliers in Germany, Japan, and France at steep prices, entirely dependent on foreign engineering. Today, Chinese-built tunnel boring machines account for close to 70% of the entire global market, a shift from buyer to world leader that happened in less time than it takes a child to grow up. Before anything can rise into the sky, though, something has to reach deep into the ground first. Every tall building, every long-span bridge, and every offshore wind platform shares one requirement in common: a hole drilled deep into the earth, wide enough and strong enough to anchor the entire structure sitting above it. Get that foundation wrong, and nothing built on top of it is genuinely safe. For the largest projects on the planet, that job increasingly falls to an XCMG rotary drilling rig, widely regarded as the most powerful foundation drill in the world, standing 42 meters tall, roughly equivalent to a 14-story building, and weighing 520 tons. The drill itself can carve out a hole 7.5 meters wide, easily large enough to park several cars side by side inside it, reaching depths of up to 190 meters, equivalent to taking a 60-story skyscraper, flipping it upside down, and pushing the entire thing straight into the ground. This rig has been used to lay foundations for some of the tallest towers across Asia, structures that sway measurably in high winds and require foundations capable of holding them rock steady against forces that would topple a weaker design. It's drilled support piles for bridges crossing open water, where ocean currents push against the structure every second of every day. And it's created anchor bases for offshore wind farms that need to survive decades of ocean storms without shifting by so much as a centimeter. Work that older drilling equipment used to take weeks to complete, and that this rig now finishes in a matter of days without sacrificing any precision along the way. A computer-controlled system continuously reads the resistance of whatever material the drill is passing through, adjusting force in real time as it moves from soft clay into dense sand and then into solid rock, applying extra force the moment it strikes a buried boulder and backing off instantly if it hits soft mud that risks clogging the hole. The operator sits in an enclosed cab watching a digital readout of exactly what's happening at the drill tip, nearly 200 meters below their feet. This particular rig has now been exported to more than 80 countries, quietly laying the underground foundations for some of the most ambitious construction projects currently underway across Asia, the Middle East, and Africa. Sometimes, though, the job isn't about precision at all. Sometimes it's simply about moving earth at a scale that's genuinely difficult to process. A standard excavator on a typical road project weighs around 20 tons and can scoop up a cubic meter or two of dirt at a time, useful but painfully slow next to one of the largest electric mining shovels ever built. A machine standing nearly 24 meters tall, roughly the height of a 7-story building, and weighing 2,000 tons with tracks alone taller than a fully grown adult standing upright. Its bucket holds 75 cubic meters of material in a single bite, roughly the equivalent of 2 full-sized shipping containers, scooped up and emptied in one continuous motion. Every hour of operation, it processes around 12,000 tons of rock and earth, and across a single month of continuous operation at a coal mine, it can pull 5 million tons of material out of the ground. It runs entirely on electricity, drawing power roughly equivalent to 50 car engines running flat out simultaneously, split between 2 separate motors, one driving the digging arm and one rotating the upper body, letting it dig, swing, and dump in one continuous motion that looks almost graceful given its sheer size. Moving loose material is one kind of job. Cutting cleanly through solid rock is something else entirely, and it matters more than most people realize, because buried beneath the ground right now are gas pipelines keeping homes warm, power cables keeping hospitals running, and irrigation channels feeding water to farms supporting millions of people. Standard trenching equipment handles clay, sand, and loose soil without much trouble, but hits solid granite or dense volcanic rock and simply stalls out. That's the specific gap filled by a heavy-duty rock trencher weighing 77 tons, resembling an oversized tractor at first glance, but fitted with a cutting chain several meters wide, essentially a vastly scaled-up chainsaw where each individual cutting link is roughly the size of a brick. That chain wraps around a boom lowered into the ground and dragged forward, grinding relentlessly through rock at 440 horsepower. The chain itself spins considerably more slowly than you'd expect, because speed isn't really the point here, torque is. The raw twisting force applied at each individual cutting tooth. Granite formations that would shatter conventional cutting equipment and send repair crews scrambling get ground through without the machine even slowing down, guided automatically by GPS to hold the correct depth and direction as terrain conditions shift. leaving behind a clean, perfectly straight trench in its wake, barely appearing to move from a distance even though it never actually stops. None of these 8 machines exist as concepts or prototypes sitting quietly in a warehouse somewhere. Every single one is already out working right now, paving roads, laying rail, lifting tunnel sections off the seabed, walking through disaster zones, boring beneath live cities, drilling foundations, and cutting through solid rock across some of the most demanding construction environments anywhere on the planet. Collectively, they explain something that pure labor numbers and budget figures never fully capture on their own: why China keeps completing projects that would take other countries years or sometimes decades in a fraction of the time. If you found any of these machines as genuinely surprising as I did, make sure you're subscribed for more deep dives into the engineering pushing the limits of what construction equipment can actually do.